So today we're going to be talking about a concept called gradient, and it's sometimes also called the slope of a line. It's a measure of how steep it is, and we've been using the letter M for gradient here. The gradient of the line also tells us whether a line is uphill or downhill, or in fact something else. So let's get our ruler and a pencil, and we're going to draw some kinds of gradients. So the first kind we're going to draw slopes upward like this. Now I imagine this to be uphill if I'm walking in the direction of left to right, so the same direction we read and write in English at least. So this line would be a positive gradient. That's the kind of gradient. Another gradient we could have would be downhill. Now when I say downhill, formally, mathematically, we would say that that is a negative gradient. So let's pop that in. Now we can also have two other kinds of gradients. If we have a completely flat line, oops, we've got to draw in pencil, not pen. So a completely flat line here, that would be a zero gradient. It's in between positive and negative, so it makes sense to call it zero. And the last kind of gradient, one that I would never want to encounter on a walking trail, is if we have a perfectly vertical line. So let's draw that. Perfectly vertical line. Now you might be wondering what kind of gradient this is. Well, it's actually an undefined gradient. So we call it literally undefined. Now the reason for this is quite interesting, and if you'd like to have a bit more of an in-depth look of why it's undefined and not positive infinity or something like that, I'll link another video for you. So the first example all we need to do is to just determine the type of gradient M for each of the following lines. So A there is in green, it's downhill, so it's negative. B is straight up and down, it's vertical, so it's undefined. C, if we were walking from left to right, is uphill, so it's positive. And D is nice and flat, so that is zero. Remember, zero is in between positive and negative, both in gradients and on the number line. Now, when we're calculating gradients, we use a special equation to find or calculate the gradient of the line. Now, I like to remind myself, I'm going to either have a positive or a negative gradient, so I like to put a little plus or minus sign at the front, reminding me, is it positive or negative? And then I do rise over run. So there are three pieces of information we need to know. Now you might be looking at that saying rise and run, what are you talking about? Well, I'm going to show you what that means. So to determine the gradient of a line, we need to do the following. First off, let's call this step one. We need to draw a right-angled triangle on our graph. The endpoints of that triangle need to go through a point exactly. So, as an example, if we have grid lines, this point here, or looking at this point here, not nice. They're not going through a really clear grid line like this, whereas this point is very clearly on a grid line. So that would be a really nice point to use. Then, number two, we're going to determine and label the following on the triangle. Every side should have a label. So the rise and the run I mentioned before, here's what they actually mean. The rise is going to be the vertical height of the triangle, so how many units tall it is. The run is going to be the horizontal length of the triangle, so how far left or right it goes. And then we're going to put a little note of whether it's positive or negative on the remaining side. Big trick here, you're often going to get negative gradients, and if you're not careful, you'll forget the sign. So this is a really helpful step to remember. So step three. We're going to substitute the rise, run, and sign into the equation for gradient M, which remember M equaled plus or minus was whether it was uphill or downhill, and we had rise over run. And then number four, simplify the fraction if possible. That's something that I know a lot of us forgot in our previous lesson, and you're more than welcome to leave it as a fraction. Improper or proper doesn't matter to me. Fractions are super helpful when we're doing gradients. So here's some examples of some triangles so we can practice that step number two. So we have a right-angled triangle here. It's not labelled in, but I can tell you that they are. Now, there's three quantities that we need to label on this triangle, and luckily there are three sides. So first off, this is a positive line. We're going to be looking at the gradient of this portion of each of the triangle's lines. So if you find it useful, you could overline that in a different colour. So this is the line we're interested in, and we're trying to find out how steep it is or calculate the gradient. So first off, the rise is how tall this triangle is. So this is going to be the rise. So the rise is equal to 1. Whereas this length here, that's the run. So the run is equal to 2. So if I was calculating the gradient, m equals plus or minus rise over run. It was positive, the rise was 1, and the run was 2. So we could just simply write a half as our gradient there. No need to change it to a decimal. Okay, the next example, we have a triangle here. This is a negative gradient, because if we were travelling from left to right, we'll be travelling downhill. This is the rise, so that's 3. And the run also happens to be 3. So when we calculate the gradient here, it's going to be, always write the formula before we use it, plus or minus rise over run. So it's going to be downhill is negative, rise was 3, run was 3, so it's going to be negative 1, because 3 over 3 is 1. Last example, we've got a negative gradient, we've got a rise of 6, we have a run of 3, so m is plus or minus rise over run. It's a negative gradient, the rise is 6, the run is 3, and then negative 6 over 3 will be negative 2. So we have a whole number for this one, that's fine as well. I've got a little interesting fact along the side here. It says lines that have the same gradient are parallel. Well, that makes sense. If they've got the same steepness, they're never going to cross. And a nice little reminder here that vertical is up and down, whereas horizontal is side to side. It is important to know the difference there. So for each of these graphs, we need to state whether the gradient is positive, negative, 0, or undefined. So that's the kind of gradient. And then we want to actually find the gradient. So when we say find the gradient, we want to calculate it using m equals plus or minus rise over run. Now, a common error alert, it isn't just asking for the kind of gradient. You need to find that numerical value using this equation here. So in these examples, we've got our lines on our Cartesian planes, and we actually need to draw the triangle that will be appropriate here. So I'll show you a way how not to draw the triangle. Don't just choose, well, don't randomly scroll up your page, but don't just choose 2 random points haphazardly. If you've got a grid, choose 2 points that are on that grid. So there's a really nice one. It goes through those grid lines really nicely. And we need to choose a second point to form our triangle. Now, it doesn't matter whether you form your triangle above the line or below the line. And also, it doesn't matter if you'd drawn a different triangle. Perhaps you'd drawn one like this, from here to here, and you drew it above the line. Regardless of how you draw your triangles, once you do the calculation and simplify your fraction, you'll get the same answer as I do. So I encourage you to check that out. So on my triangle here, I have got a positive line because it's going uphill. The rise is this value here, and that is 4. Notice that each of these jumps up by 1 unit each time. It's not sneakily going up by 2s or anything like that. Now along here, yes, this is -2 to -1, but all we care about is that this is 4 units long along here. We don't care that it's going from -2 to 2, so we don't need to put in any negatives or positives. We just care about the length of that line. So this along here is 4. So the first value we had was the rise, and the second value we had was the run. So now we calculate. M is going to be plus or minus rise over run. It's a positive graph. You're welcome to put the positive in there, but I tend to take it out in my last line of working out, and eventually when it's positive, you might leave it out altogether. The rise was 4, and the run was 4. So that's going to be positive 4 divided by 4, which will just be 1. Okay. So again, if you'd done a slightly different triangle, for example, you could have done a little one up here. you would have found that the rise over run would have been positive 1 over 1, which would also give you 1. So it doesn't matter where you draw the triangle necessarily, you're going to get the same answer once you simplify all your fractions. So let's do another one here. This would not be a very good point to do on our triangle because we're not exactly sure if that's halfway, so it would be good to avoid it if possible. Let's do this point here and this point here. And I really like it when the axes sort of form side lengths of the triangle themselves. So here the rise is equal to 3, that's that side length, and the run is equal to 2, because it's 2 units long, it's going up by 1 each time. And it's a negative line. So when we calculate it, again, got to write the equation before we substitute. Rise over run. So that's going to be negative, so glad I labelled that on my line there, otherwise I might have forgotten, negative 3 over 2. You can leave it just like that, there's no problem with that at all. Okay, let's find an appropriate triangle for the next one. I think here to here works. I notice they've provided us dots on our line, but that won't always be provided for us. So we've got a rise here of 2 and a run of 3 equals, and it's a downhill line. So M again, you're going to get sick of writing this, but it's so important to do so. Rise over run. It's a negative line with a rise of 2 and a run of 3. And look at that, we've calculated the gradient. Okay, let's look at another one. So this one here, there's quite a few triangles you could draw. You could use this point, you could use this point here, but just for the purposes of demonstration, I'm going to use this point here. Doesn't matter which triangle you draw, so long as you're careful by putting them through the grid lines and simplifying your fractions, you'll be just fine. So this is an uphill gradient, very steep one it looks like. And I've just noticed, look at these axes. This is going up by 2s, and it's going up by 2s along here. So we must be very careful with this, because normally we'd just count boxes and go, well, that's 1, 2, 3, 4, 5, 6, but that's actually 12 units long. So the rise is 12. Again, we only care what that length is. We don't care what it's going to and from specifically, just that length. So each box was worth 2, so we needed to do 2 lots of 6 boxes, which was a rise of 12. And this one would be a run of 4. Again, it's 2 boxes. Each box represents 2. It doesn't matter that it's going from negative 4 to 0. We just care about the length, the positive value. So let's do what we're starting to get very used to doing, plus or minus rise over run. So it's positive. The rise is 12 and the run is 4. We have a fraction to cancel down now. So we know the answer is going to be positive, so let's not bother writing that. And 12 divided by 4 is just going to be 3. So nicely simplified down. Even if you'd done a different kind of triangle for that, you'd still get 3. Ooh, this one here is interesting. Now, there's lots of lovely points that go on the line, but I can't actually make a triangle. So you can imagine it like this. This has no rise. The rise equals 0. It's not going up or down, but it has a run of 1, I guess. So when we do the gradient formula, we could do, well, it's neither positive nor negative. The rise is 0 and the run is 1, so that's 0. So like we'd mentioned before, you don't actually need to use this gradient formula for this kind of question ever again. The gradient is 0 because it's a flat horizontal line. So you don't need to do this in future. That's just a nice way of showing that the gradient is 0 and why. Now the next question, oh no, can't draw a triangle again. I guess we could say that we have a rise of 1, but we've got a run of 0. We're not going left or right. So this is where things get wacky. Gradient formula. So we've got, let's not put in a plus or minus. We'll put in the rise of 1 and the run of 0. Bow. If you put that into your calculator, you get an error, and that's because it's undefined. So you don't need to do that formula for this kind of thing again. You can just know when you've got a vertical line, it has an undefined gradient. Now a nice little reminder down here, having trouble remembering which gradient is 0 and which one is undefined. So remember, we can walk across a horizontal line and we give that a slope value of 0. So that one perfectly fine to walk across. We can travel along there just fine. Now a vertical line, except for Spider-Man, can't walk along that. So we're going to be falling down there. So it's an undefined gradient. I imagine a maths teacher falling down a cliff face would be screaming out undefined as they fell. So be careful not to miss negative. This looks like I'm writing a teacher's name, but I'm not. Miss negative signs. You know I'm going to give you a negative gradient question, and if you're not careful, you will miss it. So it's always important to think, is this a negative gradient? Now, a really nice alternative way of calculating the gradient, which is very helpful and has a lot in common with rise over run, is this. We have our 2 points here, so this is, it's a bit blurry, I'm sorry, x1, y1, because this is point 1, the x value and y value of that, and this is x2, comma, y2. Let's put a comma there too. So that's point 2, which has an x and a y value. So the gradient can be found by doing y2 minus y1 on x2 minus x1. So let's actually put that into practice here. So I make mistakes. You've probably noticed before. So I found a strategy I find really useful is I actually write x1, y1 on the x and y components of my first point. Now, it doesn't actually matter which point you choose to be first and which point you choose to be second. I just make the first one listed number 1, second one listed number 2, because it makes life a bit easier. Then we'll label x2, y2. Remember, every point has an x and a y. You can't have x1, x2, and y1, y2 as two separate points. It's always x1, y1, x2, y2. So now, to find the gradient using this formula, we have y2 minus y1. Remember that 1 and 2 are just labels here, not powers. And that's going to be over x2 minus x1. So y2, that's this value here. So we're going to do 3 minus. And now we're subtracting this value here. So 3 minus minus 5. So you've got to be very careful with our signs. Let's put take care with signs. Okay, now we'll put our vinculum. And now we're going to do x2, which was 4, minus x1, which is 2. Okay. So on top, if we've got 3 minus minus 5, that's going to become a plus. So that's 8. And 4 minus 2 on the bottom will be 8 over 2. So our gradient is going to be 8 divided by 2, which will be 4. Let's have a go at the next one. x1, y1. And that's going to be with x2, y2. So we always write our formula first. M equals y2 minus y1 on x2 minus x1. What some students find quite useful is putting this as a template, and then they'll put their y2 value in here, their y1 value here, x2 value here, x1 value here, and they won't forget to put those negative signs. If you find that useful, go for it. I might do that for the next couple of examples. So y2 we're substituting in first, that's negative 3. y1 we substitute in after that, minus 5. So I've got minus minus 5 there. Next, we've got x2 on the bottom, which is 8, minus x1, so minus 4 goes in here. So these two become a plus, and these two become a plus. Minus 3 plus 5 becomes positive 2, and 8 plus 4 becomes 12. So we simplify this down. 2 goes into 2 once, 12 6 times, so it's 1 over 6. Okay, can I get you to have a go at the next two for me? and I will wordlessly do them, and you can check your answers. If you haven't paused yet, make sure you do now. Okay, with this last one, if you tried to put -2 over 0 in your calculator, you would find you get a calculator error. That's not the calculator doing anything wrong. It's saying, I actually don't have a definition for what to do when I have something divided by 0. So that's literally what undefined means. It's quite interesting. So the main things here, really important to label your points. First point has an x1 and a y1. Second point has an x2 and a y2. Important to write our formula before we substitute it, which was m equals y2 minus y1 all over x2 minus x1. Careful with those signs because these negatives spawn into that formula before we've actually substituted any values. So now's a really good time to do some independent practice questions. You have 9F questions to do, and let me know if you have any troubles.